we are going to learn more advanced skills to find the integrals. Okay, it's called integration by substitution on your section 3.4, page 81. We are going to learn two more advanced skills. One is by substitution, one is by parts on your section 3.5. It's like we did this solving, say, okay, and just like that. 2 by 2, two variables, more complicated than just one variable. When this situation happens, and we have two methods, right, in your 152B class, I think. And you'll have what? First method is substitution, or another one is what? Addition or elimination, right? So when you have a more complicated situation, just instead of say, okay, like this, simple one, then you do it straightforward. But you have a more complicated situation, we have different methods. Okay, so for integrations, we did what? For integrals, we did for the basic one, the constant integrals for constant rule, or for the power rule, right? And we also have sum and difference rule. We also have what? Constant multiple rule. We also have exponential function and also log function rule for the integration, right? But for this one, even for the log exponential function, or we have what? Natural log function, right? If we have this one, that would be the natural log function, x to the negative 1. But all those tools are just a single thing, right? To do the integration. But when we have a more complicated one, later on, it's like your page 82, when we have not only just one certain power, you have other things multiplied together. Okay, or on your page 82, we also have this one, like this. So those tools, all one, is not enough for us to do things. So we need to do more complicated situation, right? Things are multiplying together. Then we need to use other methods. One is what? Integration by substitution, this section, or next section, integration by parts. Okay, so it's a different skills. Before we introduce the idea how to use substitution to find the integrals, we are going to introduce a few more symbols and terminologies we use. Okay, so we say if f of x, your model, your function, right, it's a differentiable, it means what? We are going to take a derivative this, and we can actually find it, right, if it's a differentiable. And when we use this way, then we say something called differential of the f. We write it this way, df. Means we are going to find the differential of the f. Means what? We are going to take the derivative against the x at this point. So we use the abbreviated symbol for df means what? F is a function, and this guy is the differential of the f. Okay, then we are going to see how we are going to use this concept to solve our problems. Okay, so let's practice the skills and the symbols first. So we say if my f of x to the x squared, what's your differential for the f? So you do what? You do your df, right? Then you take a derivative of x is what? 2x. But it's against what? X. We spell it out. Okay, we are practicing the symbols. Okay, if my f of x, just a simple one, okay, then take a derivative of this differential. So df is what? Log for log would be what? X dx, right? Then if we have f of x to the e to the x squared, so not only e to the x, then you need to use the chain rule, right? So df, the differential for the f, will be what? This itself times the derivative, the chain rule of the x squared, which will be what? 2x against x, right? dx. Then we have f of x equals what? X squared minus 5x plus 2. Then its differential would be what? df. Then take a derivative. Oh, this is a fourth power. So that would be what? 4x cubed minus 5. Then against x. Okay? Then eventually what we want to do is to do the integration by substitution. Okay, we are going to substitute something with something, right? So we are going to practice this if my u is x cubed plus 1. I'm going to substitute x cubed plus 1 by u later on, right? But when I take the differential each side, for this side, I'm doing what? du, right? Just like f of x. U means what? U of x, actually. So like your f of x. You take a derivative on this one, it's du. Then take a derivative on this one will be what? 3x squared against dx. Right? Then for the next one, if my e to the 2x power to t power plus 1, I'm going to replace this one with u. When I take a derivative on both sides, take the differential, what do I have? This one is my u, I take it against the u. This one I take against the t with chain rule, right? e to t, then derivative of 2t will be 2. So 2 times 2t, then against dt. Okay, so that will be the symbols and we are going to deal with. Then we do the integrals by substitution this way. So let's write down the steps first. Then we see how we are going to follow. Okay? So when situation get complicated, inside the integrals, you have more than one basic thing. Then we are going to substitute something with u, okay? So, your second part, then the steps. First one, we will let u equals the complicated one. You see why? Okay, then we will find du and find dx in terms of du. So we are going to replace whatever original dx become u. Okay, u be the complicated one. So when you replace the complicated one become u, then situation become much easier to deal with just u. All right, so we will rewrite x and dx as what? U and du. Replace the complicated one to the simpler one, okay, and integrate. At this point of time, we will integrate the u instead of complicated one x. All right, then u will be much easier to integrate. Okay, so for definite integral, you also replace, definite integral means what? You have a and b, right? That's against the x. Then when you replace with u, then for the definite integral, we need to replace x values, right, of a and b to what? With u values. Right? Because it was x from a to b. Now you have u, the u would be relevant of x, those points, right? Then when we finish the answer, we will do what? Rewrite u back to x. That's how we are going to do it. Okay? So this is more advanced skills to calculate things. So that's the symbols we are going to use with u in the place of x. And that's the steps we are going to follow. All right. So before we do that, let's review some more. Okay, so if we have, say, u to the n du, simple u, right? With the n is not 1, right? So if it's a 1, I mean negative 1, then we cannot use power rule. If just now 1, negative 1, we can use power rule, right? Go to higher level, just one level higher, right? And we are reviewing the power rule and exponential rule, right? Then for exponential, it's itself, right? Then we also, if u negative 1, if negative 1 power, we cannot use power rule, we'll have to use what? The log, right? Because if you take a log, derivative will be u negative 1. So we are doing the indefinite integral. Then we will have an arbitrary constant there. Then that's just background of the u, right? Then we are going to replace the u for the x, complicated x's thing. All right, so if we say we try to find the indefinite integral, right? For this one, cube, you can still do it. If fifth, sixth power, it gets complicated. Cube, you can just multiply out times 2x. Then you can integrate them individually, use the simple power rule. right? Then we use advanced method called integration by substitution, and it can handle more complicated situation. So we say if I have this one, make a complicated one, it's u, okay? So my u is what? If my u is x squared plus 1, then for the cube, I have what? U cubed, right? Then just happen if you take a derivative of this, would be what? du equals, you take a derivative of this side, will be what? This one against u, this one against x. So what do you have? We have 2x take derivative 2x dx. Is that right? Right? So what we have here is this part is the u, then this part is what? du. Is that right? Because du equals 2x dx. The differential of u is same thing as take a derivative of the x, then against x. So we do dx. Then when we replace that, because right now it's complicated, you have cube times something, then what do? Then we do this, right? In place of becomes u cubed against what? du. So if we do that, is that much simple? Just a simple variable with the power. Then we can use power rule to do the integration. Will become what? u4 power divided by 4 plus some constant, right? Then we integrate it. Then, but original problem is the x. Then we have to put it back. So this is our u. So how do we put it back? So we do u fourth power, 1/4 times u is what? X squared plus 1 to the 4th power plus c. Right? Okay, it's a much easier, this answer is the same thing, it's much easier. You multiply everything out and you do it individually. This way, actually you have same answers. You can try it and check. Okay, if you spell it out 4 times, it's a long one. If we have situation this, integral of x plus 1 to the cube x dx. What's the difference between these two? One is 2x, one is just x, right? But when we do the same thing, if I'm like my u equals what? X squared plus 1, right? That's my u. Then what is my du? Right? I will take a du, take a derivative of this would be what? 2x and dx, right? Then, however, for this part, we only have what? X dx. That's what we need. So, we need to have what? X dx becomes what? Half of du. Is that right? Okay, so if we do this, then x dx is only what? Half of du. Then we will rewrite the original one becomes what? This is the integral of u cubed times what? Half of du, right? Then you take a half out, Then you integrate u CQ du, right? Then that will be half of, this one would be what? Same thing, u4 over 4 plus c, right? Becomes what? 1/8 of u4 plus 4th power plus c. That would be what? You have to put it back for the x. Then x, u is what? X squared plus 1. So you have 1/8 what? X squared plus 1 to the 4th power plus some arbitrary c. Okay? So what we want to do is eventually to just integrate the u with du, right? So we can use the simple rule to finish the work. Let's look at the next page. Situation like this, definitely you need those more advanced method, right? Like e to some kind of power like this. But you have more things, then you cannot use any simple rule to do that. Then we need to borrow our u, okay? Then we say make u the more complicated one. So which one looks more complicated? E to the power, more complicated than just x, right? So what we do is we make a u equals e to the x cubed, right? Then we want to integrate some kind of u to the power to the du. That's the idea. Then we can use the power rule to do that. Then we see what's your du, right? So you take a derivative du on this side against your x, right? Differential of u would be this one, take a derivative of x. Then you follow the chain rule, then you have to have e to the power, then take a derivative of 3x, x to the 3rd power is what? 3 to the x squared. Is that right? Mm-hmm. Mm-hmm. You can do it this way. Okay? If we do it this way, what do we have? Let's see. So then we will have what? du equals 3 times x cubed to the x squared of dx. Is that right? So if you do it this way, this becomes what? That's your u is this, right? Now your du is this. And this whole thing becomes what? Ex cubed x squared dx becomes what? 1/3 of du, right? So if you compare this and this, then whole thing becomes what? 1/3 of du against u, right? So then 1/3 becomes constant rule. So you do one level higher would be what? Take the constant out, become u, right? Plus c. Is that right? Okay, but you have to answer back to the x. So this one would be what? 1/3 u is this guy, e to the x cubed plus c. That would be your answer. So you will have a problem with those advanced integration methods. We are not going to emphasize on those skills for our purpose. But so often we might have to use it if the model is complicated. Okay? Or we can do it this way. E to the x cubed x squared dx. Okay? Just happen if you see it this way. You say, oh, 3x cubed, take derivative would be what? 3x squared. And x squared is here. So you might be able to do that. So you say, oh, if I let my u become x cubed, if I do that, instead of e to the x so many powers become e to the u power, then we can just use exponential integration rule, right? So if we do that, what do I have? My du will be what? 3x squared dx, right? Then I will have this part just like that. Then I will have what? The 1/3 du becomes what? X squared dx, right? If we do this way, then we can simplify original integration becomes simpler, right? I can do it become this way, e to the u power, right? U is x cubed, because I want to have this one, so I can use this rule, right? So then this part becomes what? X squared dx is what? 1/3 of du. Is that right? Then I can take 1/3 out, eu to the du, right? Then we take the exponential rule for this. That will be 1/3 of what? Just itself, right? Plus 1/3 time constant, still a constant. Then for our answer, we need to put the u back to x. So we have what? U equals x cubed. That will be 1/3 e to the x cubed plus c. Is that right? Do we have same answer? Yes. There are many ways to make original integrations much simpler by substitution of u. To make a situation become c, x cubed, x squared, you only have what? Single thing to integrate. Same thing here. If you do this way, you only have what? Constant to integrate. Then you follow the constant rule of integration, and this way you replace the power. So there are many ways, but you need to use what? Substitutions to do it. Otherwise, it's hard to make it. All right. Let's see the next example. Recovering cost from marginal cost. Page 83, right? A company's marginal cost function is this. And fixed costs are $1,000. Find the cost function. So somebody did a study, say marginal cost for each unit, next unit will cost you that much more, right, for next unit. So for x is your units. Then fixed cost is $1,000. Then find the cost function. So it's much more complicated models, right? Then how do we find the cost? Then we say, if you take a cost function, if you take a derivative of the cost function, that's your marginal cost. Then you do the reverse, take the integration of the marginal cost, then it will be your cost function, right? So we do the MC, so write this way. So we say cost function is integration of the marginal cost function. right? So then it's indefinite integral. Then it is what? X cubed over, that's the model, dx, right? Then how we are going to do it? So you take a look at this, then the connection you will have is if you take a derivative of x fourth, then that will be x cubed. Okay? So what we want to do is let u be the bottom one, the complicated one, right? So let's do that. Then if you take a du, then derivative will be what? 3x to the cube, 1 is gone, right? Then if we replace this integral, what do we have? That would be, that's your u, right? X cubed, and that's to the x, right? So for this portion, x cubed and dx will be what? 1, let's see, oh, then I was thinking, right, that should be 4, right? So then x cubed, what do we have? X cubed dx will be what? 1/4 of du, right? So we will replace this part x cubed dx to be what? 1/4 of du, right? After the substitution, then what do we have? Take 1/4 out, we have 1 over u du, right? Then become a what? Simple integration. 1 over u, you know, the power is -1, so that's your log. So what do we have? We have 1/4 natural log of u plus c, right? Indefinite integral. Then we also have what? The fixed cost of $1,000 to help us to find the c. However, before we do that, we were doing the x, so we have to put it back first. So it would be 1/4 natural log. U is what? It's here, right? Plus 1 plus c. Okay? So for this marginal cost function, for its cost, if x is 0, right? When x is 0, it should not cost you anything but the fixed cost. So what do you have? You plug in 0, right? You're supposed to be what? 1,000. So you plug in 0 for x. So what do we have? 1/4 natural log 0 to the 4th power plus 1 plus c equals what? 1,000. Then 0, so that will be what? Natural log 1. What is natural log 1? Natural log 1 is 0. Otherwise, you just punch into the calculator. So that's 0, then that would be 1,000. You need to find your c, right? So what's our cost function? C of x would be this guy, all the way here, right? So that would be 1/4 times natural log. Originally, we need to write x4 plus 1 as absolute value, but they are the same because x to the 4th power is positive. So this guy is always positive. So you can just use the parentheses, or you can use absolute value plus your c. So that would be your cost function. That means when you produce 1 unit, how much the total cost would be. Then produce 2 units, how much total cost would be. That's how you do, right? So that's your cost function. Let's see, next one. find the integration by substitution. This one x cubed minus 3x to the x squared minus 1 dx. Okay, so it's much more complicated, and we cannot even multiply them out and do it individually, right? Because the chain rule is involved. So we say, what can we do? We use the u to be the complicated one. Then you can see inside x cubed minus 3x, if you take a derivative, it will be what? 3, just take a quick look, it would be 3x squared minus 3, right? Then it's very similar to here, except the 3. So then you start to get an idea, if you make this one as your u, right? Then somehow this becomes u to the half power. Then this guy, something to the dx, can be replaced with something with du. Then you can integrate them, right? So if you make u this way, du would be what? 3x squared minus 3x to the dx, right? Very similar to here. So that would be 3x squared minus 1 to the dx. Then you compare what we have left, then you will see x squared minus 1 dx will be what? Divided by 3 would be 1/3 of du, right? So those are just basic substitution you can apply. Try to adapt, right? So what do we have here? We have, that's your u to the half power, right? Then this guy is what? 1/3 du, right? So you integrate u instead. So you have 1/3, this 1/2 du. Then you can use power rule, because the power is not -1, so you use power rule, bump up one level. So that would be what? U to the 3/2 divided by 3/2, right? Plus your indefinite integral constant. So 1/3 divided by 3/2, then will be 1/3 times 2/3, right? So you will have what? 2/9 to the u 3/2 plus c. Then the final answer is for the integration for x, you have to put it back. So your u is this guy, right? So it's 2/9 then x cubed minus 3x to the 3/2 power plus c, right? Okay, let's check next one on your page 84. So to evaluate this, e to the square root of x, x to the half, and dx. So you take a look. Try to see if you use the u, then the remaining x and dx thing will be replaced by u. Okay? Then when you see this, you find out that's x and a half. You take derivative, that would be what? Drop one level, -1/2, right? So this guy is related to this guy. So let's do u becomes what? Square root of x, which is x/2, right? Then if you take a du, drop one level, x, -1/2 of dx. Is that right? Your u and du. Then we want to have this. That's what we want. So your x -1/2 dx will be what? Times 2, that would be 2 du. Is that right? So if you use this substitution, that would be the square root of x would be your u, right? Then x negative half dx would be what? Your 2 du, right? Then it becomes what? You can see if you take a 2 out, then it will be eu du. That will be a simple exponential functions integration. Eu is e to the power would be itself. That would be what? 2eu plus c. Is that right? Okay. But you don't leave the answer there. What else you need to do? Put it back to x, because that was the integration for x. So that would be 2e. This is x to the half. It's the same thing as this. Or I can just write x to the half. They are the same. That would be your answer. Right? So we are practicing the skills for the integration by substitution to solve more complicated model situation, right? Okay, let's see the next one. Those are all indefinite integral. If we have definite integrals, what we are going to do? If the bottom just x, then you know the integration for 1 over x is the log, right? But it's not. So we cannot do that. So we have to replace this guy with u. Okay, so we can do 1 over u to the negative power. So we can do the integral for the 1 over u, which is a log, right? So we have to make this one 3 minus x. So replace the bottom one. Then if I do that, my du would be what? Negative, right? 1 negative x. Is that right? So that's what we have. But what we want is dx to replace here. So then you will have what? Dx equals what? Negative du, right? So we put it back over there. So what do we have? 3 minus x is your u, and dx is what? Negative du, right? Then what happened? We were doing the x from 4 to 5. Now it's no longer x. We have to find the u, right? But from here, so what do we have? We are going to do u. So x was what? 4 to 5. Then what happened to the u? X is 4 plug in is a negative 1. X is 5 plug in. U is what? Negative 2. So from 4 to 5 become what? Negative 1 to negative 2. Right? Then we calculate from there. So for definite integral, so we take a negative out, right? So it will be negative 1, negative 2, 1 over u du, right? So that would be the log integral for u to the negative 1 power. So what do we have? Negative natural log of u, right? The whole thing is from what? Negative 1 to negative 2, right? Then we find the definite integral by plugging. So negative 2, that's first number, minus second number, that's negative 1, right? Then you know natural log inside of natural log shouldn't be negative 2, a negative number, right? But after the absolute value, that would be natural log, that would be what? Just 2. Then minus become plus, become natural log of 1, right? Then what is the natural log of 1? which is 0. So that would be natural log 2. So that would be your answer. We are practicing what? Integration by substitution. Right? If a model is complicated like this, that's the method you will use. Let's look at the next one. Finding total population from a rate. Okay. Oh, not the population, pollution. Okay. So, pollution is being discharged into a lake at the rate of what? As such, rate equals 400 T according to T must be the time, right? So many tons of pollution per year. T is the number of years since measurement began. So find the total amount of pollutant discharged into the lake during the first 2 years. Okay, so it wants to find the first 2 years. So the T is what? For us, it's from 0 to 2, right? Then that's the rate. Then total is what? The antiderivative of the rate, right? Derivative of the function would be the what? The rate of change. The antiderivative of rate of change would be the pollution total. So the total would be what? By the antiderivative for the first 2 years we are talking about, then 400 T ET squared against the time, right? Then it's complicated. So what do you think? We can do it this way. We practice the few like this. E to the some power with x there, right? So what do? Because you can see T squared, take a derivative, will be what? 2T, right? So you can get rid of T and dt with that. So you can make a U equals what? We don't need to do e to the t squared. You can do that, but we just use a simple one. Okay? Then du will be what? 2t dt, right? Derivative. That's what we have. Then we will replace this one becomes what? For 2t. Okay? So let's see. We want to replace what? T to t. So T to T would be half of du, right? So we'll have what? So we can replace this and T dt becomes something u. So you have 400 e to the t squared is what? U, right? And T dt becomes what? Half of dt, right? However, the 0 to 2 years no longer to become no longer 0 to 2, right? So t was what? 0 and 2. From here, then we want to find the u would be what? 0 squared is u, t squared will be what? 4, right? So we are going to do 0 to 4 now. Right after the substitution, then we cleaned up. That would be 200. So we will have what? 200, 0 to 4. Then et. Oh, that would be what? Du. Look at that, du. Right? So that would be eu du. So we have simple exponential function integration. Right? Then we will plug in 200e, the integration EU is EU from 0 to 4. Right? Then you put it back in with the u values. Then what do we have? We have 200e to the 4th power minus 200e to the 0 power. Is that right? E to the 0 is 1. Then you just plug in your numbers to get the actual number. So it's 10720. So what does this one tell you? It tells you, right, is how many tons of total pollutant would be in there. So you say it will be 10, 70, 20 tons of pollutant were discharged into the lake. Right? Let's see another example using integration by substitution on your page 85. Finding average water depth. It says after X months of the water level in a newly built reservoir is this one. The level is so high. 40, somebody did a study to measure it. Okay, so many feet. And find the average depth during the first 4 months. This is a per month water level, right? So we want to find what? The average depth per month during the first 4 months. Okay, the level is total after X months. Okay, X is your month. So in case you work for Department of Water Resource in California, or you work for what? Water and Sewage Company here in Tahoe, then some environmentalists then studied and say, oh, water level is in such way, okay? Then we say, okay, this year 2020, what was my first 4 months from January to April? What's the average, the water level? So we can see how we can predict coming summer, do we have a drought or not, right? So our month is what? From 0 to 4, first 4 months. Okay, then remember how do we do our average? Let's see, which page was that for the average thing? So you need to look at your page 74, okay? So on your page 74, it says what? Your average from A to B would be your, this way, integration, from B minus A for the integration A, B for your curve, right? Whatever your model is, then you do that, that means average. Okay, so if we use that, your average would be what? 4 minus 0 is 4, right? 4 minus 0. Your integration is 0 to 4, right? Then you use this function you have against x, right? Then we want to find out how we are going to do that. Then it's not a simple rule for the integration, so we need to figure out the substitution if we can do it. Then you take a look at x squared. Take a square, take a derivative will be 2x. Then that will be our x and dx, right? Then we say, okay, if I let the inside complicate one, u will be your u, right? Then my du will be what? 2x dx, right? Then what I want to replace is x and dx. So my x and dx will be what? Half of du. Is that right? So what do we have? 1 over 4, right? So 40 and x squared plus 9 would be your u and half power. Then x and dx would be what? X and dx would be half of du, right? For definite integral, you will also consider the beginning and the end. So the x was what? 0 and 4. Then we want to do the u. When x is 0, u is what? 9. When x is 4, square u is what? 25. Is that right? So we need to replace this from 0 to 4 become what? 0 to 4, 9 to 25. Right? Then we move the constant outside. 40, 20 divided by 4, that's 5. You have 9 to 25, u to the negative half to the du, right? So from the more complicated one for the integration, then we make it become a simple power rule. Then we can plug in, right? So that would be 5. Then take an antiderivative one level higher, that divided by 2, right? It will be u to the half power divided by 2 is the same thing as multiply by 2, right? From where? 9 to 25, right? So you plug in, that would be 20. So what does that tell you? It means what? We are talking about the average depth of the reservoir over the what? The last 4 months. That's what we are talking about. The average was what? 20 feet. Right? So that would be our section 3.4, integration by substitution, with more advanced skills for more complicated models like those, with E, with more power, with X multiplication. Then we make a simpler, become a simple integration, use those simple rules to do the antiderivatives.